Good morning, ladies and gentlemen. Welcome to the International Conference on Research for Social Devotion in commemoration of the 50th anniversary of Khon University. I am Sirayu Pawana from the Faculty of Humanities and Social Sciences, and I will be an MC today. Okay. So before we begin today's sessions, which we still have a few minutes, please let me briefly inform you of the schedule of today's conference. In a few minutes, the first keynote speech on grand challenges in informatics, big data-driven ICT, innovation in cyber-physical integrated society will be given by Professor Noboru Sonehara. Okay, and followed by the second keynote speech on humanoid robot for senior society in the 21st century, delivered by Professor Voga Garafe, head of the Intelligent Robots Lab, Faculty of Aerospace Engineering from Germany. After that, the oral presentation sessions will start at 10 o'clock, and there will be a 15-minute coffee break at 10:30 to 10:45. We'll proceed to the oral presentation till lunch at 12. And in the afternoon, we'll come back with the oral presentations at 1 o'clock. And there will also be a 15-minute tea break at 2:30 to 2:45 before we continue with the rest of the oral presentations until 3:30. And we'll also be hearing the closing remark at the end of today's conference, together with the ceremony for the bestowal of the conference's best presentations. Okay, at this moment, most distinguished guests, ladies and gentlemen, let us proceed to the first keynote speech. I'd like to take this opportunity to invite Professor Noboru Sonehara from Information and Society Research Division, National Institute of Informatics, School of Multidisciplinary Sciences, to begin today with the keynote speech. Under a topic of grand challenges in informatics, big data-driven ICT innovation in cyber-physical integrated society. Please join me in welcoming Professor Noboru Sonehara as the first keynote speaker of today.
Good morning, everyone. So I'm very happy to attend this international conference on research for social devotion. And also congratulations of 5 years Khon University. And I would like to self-introduction. So I'm a director of Information and Society Research Division, National Institute of Informatics, NII, in Tokyo, Japan. And my colleague, Associate Professor Vanida Kanakad, this is first call, of Khon University, was visiting researcher in NII. And also, I was a dean, a graduate university for advanced studies. So NII has a graduate school. And Dr. Naralata, she is lecturer, I think, of the Khon University. And she has graduated from the informatics of Sokendai. So this is a reason why I come to here. And I also project leader of data-centric social science research organization of information and system, ROIS. And this is my, next I will introduce my career and future plan. So about 26 years I worked for NTT. It's the same company as TOT in Thailand. And I developed facsimile communication. And after that, I moved to ATR, Advanced Telecommunication Research Institute International. And I doing the research concerning a neural computing system. After that, I moved back to the NTT, and I was a director of the digital commerce. And I exit a private company and to the move to university. So National Institute of Informatics, just character T is changed to I, NTT to NII. But salary was reduced half. It's a joke. So I'm a researcher of the data-centric social science and data-driven innovation. And I am planning to move to NII to Konkan University from 2011, 18. So if you agree, so big data-driven ICT innovation center. Oh, okay, so I will show you National Institute of Informatics, NII, and Sokendai. So left side is NII, so which is located in the Tokyo station in Japan. And neighborhood is Emperor. So my research floor is located on the 18th floor. We can see the inside of Emperor Palace. So if you come to Japan, Tokyo, please call, inform me. So you can see the inside of Emperor Palace. And Sokendai is located on the Miura Peninsula of Kanagawa Prefecture. So this university educate of research for the scientific field. Okay, so I will talk with the grand challenges in informatics. So first of all, I will introduce cyber-physical integrated society. So it's being formed. And second, so big data-driven ICT innovations. And third, big data and data privacy. This is a key issue in this field. So what happened 2020? This is a quiz. Of course, 5 years later, so 50, I don't know, you have such event, 55 years of social devotion of the Konkan University. So, answer is 2020, the Tokyo Olympic and Paralympic Games. Okay, so in this Tokyo Olympic and Paralympic, Japanese, we show to the all over the world the reconstruction from the 2011 March 11th. We had a great East Japan earthquake and tsunami. more than 20,000 people died. And second is safety and security of cyber physical society. And third, so we need social innovation, not only social devotion, but also the social innovation, strongly needed. So we will develop the big data-driven ICT innovations. And also, we will show you the 2020 in Tokyo Olympic electric vehicles and autonomous cars will show up, I think. So next speaker is related robotics. Perhaps I think this is related a little bit. Okay, next. So what is a cyber physical integrated society? So it's an integration between cyber and physical world. So you know ICT devices and sensors such as a smartphone or some smart grid of every kind are connected to the network. And information is digitized and allowing anyone to access it anytime. So integration or federation between information space, it's a cyber space, and the real world, it is called the physical world. So in another word, cyber physical integrated society is being formed. So what is a cyber physical integrated society? So lower layer, so physical world, so shop, financial institution, building, public facility, home, school, hospital. So the many information is collecting as a big data in the cyberspace. So in the cyberspace, we will do the smart grid or e-commerce or relational policy making or decision making. So this interaction between cyberspace and the real world will be more important. So our research is to solve the social problems. So as I mentioned just before, so lower layer, physical world. So environment, energy, facilities, medicine, food, disaster, and so on. And cyberspace, this is realized by the information and communication technology. And also data by the smart device or smart grid or every kind of sensor is stored, collecting and stored in the cyberspace, so big data. So we have to use, we have to analyze big data and provide the feedback to the service. So this is a big data-driven system. The most difficult problem in the real society, so there are many problems, but one point is the subject to decision making is based on the incomplete data and partial data and incomplete knowledge. So we have to, for the management, or, okay, sorry. So we have to do the decision making by the partial data and incomplete knowledge. So data analysis and data-driven service is needed. So data-centric social science. So to support relational decision making. So we are collecting the diverse and massive amount of digital data, so-called big data, in the web, SNS, and smartphone devices. And we are doing research to create a new data-centric science based on the analysis of the data and the synthesis of service. I will show you big data-driven ICT innovation. Just example. So next generation ICT, so human and social activity at the physical world reflected in cyberspace. And the power of data or power of information. So I think it's intelligence brings about data-driven information service. So we have to sense the human social behaviors, so analyze data, synthesize service, and provide feedback in the timely manner. This is a very important technology. So big data driven system is like this. Left side, cyberspace, human and society, and this is cyberspace, and lifelong location data, communication history collected, and record of the activities in the human and society. And social data infrastructure analyze the web, SNS data, communication data, and also public statistic data. It is called open data. And data management, data anonymizing, or another credibility evaluation, and we have to provide feedback for policy making or decision making to the human and society. So this is so I will show you the example of web data-driven tourism and disaster prevention. Okay, thank you. So demand is like this. Public policy supporting system. So in this system, supported by the Kyoto City. So demand is local government wants to know the daily number of tourists because Kyoto City is a very good place if you have a chance to go to first to Kyoto. Okay. So this is every year 20 million people can visit to Kyoto City. So local government, Kyoto City, wants to know daily number of tourists. And they want to know the daily congestion in Kyoto area. For example, traffic system or a bus or a public bus or something like that. And also they want to know the number of tourists in emergency. So in Kyoto, we have some saturated water, rain. So many people cannot, 2 years ago, many people could not go back to home. So approach, we developed the tourist estimation system based on booking long data from the integrated database. So booking long means if you come to Konkan, so in my case, I access to several web reservation sites. So Pullman is vacant or occupied or how much, okay? So our system is provide big data collection. So as I mentioned, many data-centric public policy are realized. So, but many cases using the social survey data. This is not real time. Okay, it needs of 3 months or half year. So we want to realize to the online, real-time population density or something like that. So we use web reservation data, so booking log data is used for public policy. How do I do that? So, for example, Pullman Hotel. I stayed in the Pullman Hotel. So Pullman Hotel have to get guests from many media. So upload Japanese web reservation site or local government website or some other website. In Japan, mainly 2 or 3 major reservation sites are existing. So every hotel upload to such system. So every day I looking for the I am looking to the situation of website. So which hotel is available or not. So not only vacant or occupied, but also the facility price. Facility means this hotel is designed for the barrier-free or not. It's a very important information for senior people or handicapped people, or price or occupied room or reservation station or some events or reputation. So this is a kind of inverse problem. So we can see only full booked or vacant, 1-0 problem. But every day, if you look at every site, and Pullman Hotel is available or not, how much in this season is some event is related or something like that. So we get this real data, in this case, total number of booked room from the web data. So real world and web reservation booking site is like this, and we have to solve the inverse problem or only observe data. So this is a result. So this is a Kyoto city. In Kyoto, major hotel is 178. In Japan, we have more than 20 major, 20,000 hotels. So it's a major mean the employee is 10 employees. It's a big hotel. So this is a comparison with the statistic data and estimated data. The blue line shows estimated data from the web booking data. And yellow line shows the social survey. So each data, social in the statistic data, so every month only one time data is obtained. But our system is every day. Pullman Hotel is occupied how much or something like that. I don't know how many hotels in Konkan. 20? Oh. Okay, so this is the evaluation of the data reliability. So conclusion. So left side compared to the statistic data and estimated data. So error comes to less than 9%. So we can use it. And also this system provides price prediction. Next year in this season, Pullman Hotel, how much? And this is price and work rate prediction. So local government wants to know how much tourists or business people stayed in Pullman Hotel. So this is a total system. So local government want to do the tourism policy making or decision making. So price prediction, and this figure shows the Kyoto Station. Is the center circle shows the Kyoto Station. Within 500 meters, within 1,000 meters, and within 2 kilometers. So how many hotels are existing around the Kyoto Station, and how much, which hotel is vacant or occupied? So we can see, if you want to know, you access to this site. So you, next week, how much you can know. So economic effect evaluation. So how many hotels in this area, for example, Konkan local government wants to know how many hotels in this area or how many guests in this area. So price estimation or visualization situation, current situation. Also, it is possible to congestion or estimation and the visualization current situation. So this is another, okay. So same system is applied to evacuation and navigation. So this disaster mitigation policy making. So we are collecting lodging facilities and Shinkansen. Shinkansen is the first train from the in the Japan, and stayed in Sendai City before and after the earthquake by booking log analysis to support for this disaster mitigation, such as efficient resource management. So this is a result. So this is a blue line shows state of Shinkansen recovery. So unfortunately, March 11th, so we had the earthquake. So every Shinkansen and hotel is shut down. And Shinkansen case is April 26th, it's recovered. But limitation of the number of the trains and the speed of limit and rate is before the earthquake 100%, but April after the disaster becomes to 56%. So it's a kind of resilience. And also hotel is earthquake happened. So every water, electricity, infrastructure shut down. So gradually increasing the state of hotel. And it becomes to 60% after 2 months after earthquake. So you can use this information, so hotel or transportation system management by the local government. So this is the final. I have 5 or 6 minutes, I think. So this is a society with surveillance cameras. So I don't know. No, okay. This is London and Tokyo. And Japan, 2010, more than 3.5 million surveillance cameras. And England becomes the 4.2 million surveillance cameras. So this is a Google, large-scale privacy protection, a Google Street View. So upper side, so there is a Google catch the face, human, and they anonymize. But the lower side is a car, so a car number. So present gives face present technology. So face recognition becomes 89% who are working in the and car number recognition becomes 95%. If I don't know. So this is the real situation. So future seeing. So this is the normal seeing of the this. We can see everywhere in Konkan. So the car, how much this car and clothes. So how many children in this house, and this bag is brand or not. If you use Google Glass, so everything is resolved. So only privacy protection. So you can see this kind of here. So I want to say that balance protection with utility of the personal information. Okay, it's a kind of balance of utility or protection or convenience or security. So my idea is like this. So vertical axis shows the protection level. The horizontal is a utilization level. So at present, we have, in Japan, we have to design only single service vector. But I think the right of self-information control and user has to have freedom of the service selection. Okay, so if you high security oriented service, so you will select blue line, blue vector. But if you disclose your information, you have what kind of hobby you have. So in this case, information-oriented service. So user, consumer, student can have the freedom of the service selection. So this is the principle of identity data commons. So first, the degree of disclosure can be determined based on one's own choice, and ensure the user freedom of the service selection, and the license of the data given to the user, and how information is handled is determined based on the license. So second graph shows bars. So there are four kind of license. So first is anonymous. So this license can be used only when the data has been technologically anonymized. And second is the BARTs. So if this data is not is used only in non-commercial use, so it can be used on the non-commercial purpose. The third is emergency. So where we are, and my mail address or something, mail address to the my family. So it can be used only during emergency. So and the last is termination, period of use. The duration of the preservation of the personal information is X years. Afterward, it is deleted. So this is a system configuration, license, purpose, and the commercial domain or public domain. So at present, I want to realize the ID data common during emergencies. So appropriate rescue or relief plan can be quickly determined by collecting, understanding personal information and individual attributes. So, for example, where a person lives in a stricken area, if he or she is child or adult, or there is someone who can help him or her, or she or he understand Japanese. This is very severe problem in the Japanese grade East Japan earthquake and tsunami. So in Japan, there are many students or foreigners, but only announce is Japanese. So every people ask to me. So it's a very difficult problem. So adaptation to the foreigner or its language. Some people ask to the Mount Fuji will be or something like that. And Germany ambassador moves to Kansai, and French ambassador hired airplane, and 2,000 people of the mainly student go back to France. It's a real situation, not joke. So conclusion. So cyber integrated society is being formed, and big data-driven ICT systems and service for social innovation, and harmonization security with utility of personal information. So this is a small, not small, this is a kind of proposal to KKU. So the collaboration research concerning the book-long big data-driven ICT system and service, and data-centric social science or decision-making support systems. And third is big data and data privacy, so ID data common. It's a candidate of the research collaboration. Okay, thank you very much for your kind attention. If you have a question, please ask Wanida-san or me. So this is mail address. Document is the having Wanida-san. Professor Wanida has my presentation document. Thank you very much.
Thank you very much, Professor Noboru Sonehara, for the interesting speech. Okay, it's interesting to know, to learn more about what's up with the ICT today. Okay, and it's very clear that ICT is becoming involved in our daily life in every aspect. Okay, well, is there any question to ask Professor Sonehara? Okay, I don't think there's any question for Professor Sonehara now. Okay, maybe you can ask him later. All right, let's continue on the second keynote speech today. It's under the topic of humanoid robot for senior society in the 21st century by Professor Volker Karafe, head of the Intelligent Robots Lab, Faculty of Aerospace Engineering, Wanderweiner University München, Germany. Please welcome Professor Volker Karafe to give today's second keynote speech.
Thank you. Thank you very much. I hope somebody would help me to insert my little USB memory into a computer. So we made it. I will talk about robots and robot technology and about the design process that we will need to implement in order to develop those robots that we need in the future to help people, to help ordinary people. Whoops. Problem? Okay. So, as I said, I will talk about robots. And first of all, when people hear the word robot or when they think of robots, usually they think of industrial robots. Industrial robots are intended to manufacture things, to produce things, and they are very useful. But they are not intelligent. Their strength is that they can do the same thing all over again, always with the same high precision, and it makes it possible to produce many things very cheaply and very high quality, like mobile telephones, motor cars, and so on. But they have no intelligence. So I will not talk about them today. There's an evolution in robotics, and the next step in this evolution were service robots. They are not supposed to produce anything. They are supposed to provide services such as transportation or cleaning, something like that, or to help people provide services, for instance, in the maintenance of machines and systems. They are more intelligent than industrial robots, but they are also specialists. They can perform only one kind of work and in only one kind of environment. The next step are personal robots, and there are two kinds of personal robots. The first kind is like toys. Especially in Japan, they are very popular. They are little machines that are intended to entertain people or to make people happy or make them feel less lonely, but they do not do any really useful work. What I will talk today is a second kind of personal robots. They are supposed to work like butlers or maids. They are supposed to help people in their households or in their working places. And they should be very flexible and intelligent. They should be easy to communicate with. And the big difference between these robots and the industrial robots is they are much safer. Industrial robots are dangerous. So when an industrial robot is working, usually there's a fence around it, and when some person goes through the fence, the robot will immediately stop because the robot is very strong and very stupid, so it's dangerous. But in the future, we want to have robots that coexist with people, that exist in the same house, in the same apartment as ordinary people. And they should cooperate with people. Like if I want to carry this table, here I work and there the robot works, we both cooperate. So the robot must be very safe. It does not hit me. Now, what are the trends that make this evolution possible? Everything has become better. The robots have gotten better sensory abilities. They have more powerful information processing, more intelligence, and well, they are more flexible, more adaptable, because they are intended to work together with robots immediately, and they can do a large variety of work in a large variety of different workplaces. Now, why is it difficult to develop such robots? I haven't mentioned it directly, but such robots do not exist yet. We are trying to construct them, but we cannot. So they present great challenges, and the reason is they are extremely complex systems, and they are, in order to be really useful, they must have levels of safety, of intelligence and dependability, maintainability, and so on, that far exceed today's technology. And therefore, they present great challenges to more than one generation of engineers, and that makes them interesting in an academic sense. So one important aspect is that in order to build such robots, we should use a systematic design process, because there are so many difficulties. If we don't work systematically from the beginning, we have no chance to be successful. And we developed a systematic design process that is sketched here. The most important item is that we decided to learn from nature as much as possible. I will explain in more detail a little later. We should place much emphasis on the communication abilities of our future robots, because we want the robots to communicate with ordinary people, not with robotics engineers, but with people who have no interest in robotics and no knowledge about robotics. They should be able to use the services of robots, so it must be easy to communicate with them. The next 2 points I will skip today for lack of time. And number 5 is field tests. It's very important to have field tests to test the robot in a real environment in all stages of its development. And in order to do that, we must build a real robot. It's not enough just to have simulation and to have a robot that exists on paper. No, we need a robot that exists in the real world, and we want to study its behavior in the real world. Then we can make progress in the development of truly useful personal robots. So this is the robot that we have built in my laboratory. It has the size of a large human. It's indicated there, 1.85 meters tall and rather wide. I don't want to go into the detail. Its main sensor is a vision system with 2 cameras, and also it has a microphone to allow speech understanding. The manipulation system consists of 2 arms and a body that can bend forward and backward. It has an omnidirectional undercarriage and a multiprocessor system to do all the information processing that's necessary to control such a robot. So now I will discuss the concept of learning from nature. Why should we learn from nature? The reason is that when we look at organisms, we find they are very complex systems, they are very efficient, and they are very dependable. Much better than any technical systems that we can build. So I think we can learn a lot by studying natural systems, organisms, and try to learn from them what makes them so efficient, so effective, so dependable, and so on. They have been, they have evolved under the pressure of evolution over billions of years, and that makes them so good. And we don't have that much time in engineering, but we want to learn the important principles that evolution has produced. So we try to use as much from the concepts of nature as we can. And here are some examples what we can learn. We can learn the human-like sensor modalities like vision and touch and hearing. We can try to use human-like information processing inside the robot, because if the robot has a similar way of information processing as a human, then it may be easy to communicate with this robot. For an ordinary person, it will be easy to communicate with the robot because the robot has, in a sense, a similar way of thinking as the person. Then we want human-like size and kinematics. The reason is that our houses are made for humans. The light switch is in a height where I can easily operate it, the door handle, and everything is made for humans. So if the robot has a similar size and similar kinematics as a human, then it can easily use all those facilities that are intended for humans, and we don't have to rebuild the house for the purpose of the robot. It should have a human-like communication method. So we humans know how to communicate with other persons, not only by talking to them, but also by looking at their faces, looking at their their gestures, I'm sorry, their body motions, and so on. So the robot should have similar means of communications. It should understand all the multimodal communication that humans used, and it should produce similar signals as humans do. Then ordinary people who are not interested in robots can communicate with a robot. The other points that are listed here are of a more technical nature, and probably today they are not so interesting for today's audience, so I will just skip them. Oops, that was a mistake. Now I will go a little bit into the details of the points that I mentioned before. I begin with sensor modalities. Today's robots usually use very special sensors. They use sonar and radar, and they use laser rangefinders, imaging laser rangefinders, as you see in the upper right of the image. It's totally different from the sensor modalities that nature has developed. In nature uses something like vision and audition, touch. Also, although we are not using it, olfaction and gustation. So totally different sensor modalities, and we think there's a reason behind that. So we believe we should give our robots the same sensor modalities that have proven successful in nature, and then we hope to have results that are as good as in nature. Another point is robot control. The traditional approach to robot control is based on exact measurements, on perfect knowledge of everything, of the characteristics of the robot and of the environment, on careful calibration, and it is based on control theory. Control theory is a very nice mathematical theory. So the method that control engineers apply is they make a mathematical model of the system they want to control. Then they operate with mathematical means on their mathematical model, and they derive some conclusions. Well, in robotics, experience shows us that this approach is not successful. The reason is essentially that the model never exactly reflects reality, and as soon as there's a difference between the model and reality, this model-based control fails. Just as an aside, we have a similar situation in economics. Our economists use mathematical models of society and of economy, and as we can see every few years, their models are incorrect, they fail, and it has almost disastrous consequences. So what we propose is a nature-inspired approach that is quite different. We, at the beginning, we realize that all our knowledge will be vague, and it will be approximate, and it will be incomplete, and the environment will never be the same. It will change all the time. It will change in an unpredictable way. So we must accept that. And if we base our control on invariable models, then they cannot be consistent with reality. So instead of exact measurements, we use perception, which is a more qualitative way of looking at the environment. And instead of control theory, we use situation-based selection of behaviors, and the robot has a predefined set of behaviors, and the control is achieved by activating and deactivating certain skills or certain behaviors. This is similar to our human way of operating. If I wanted to go out of this room, I would look around, I see, oh, there's a door, and I know how to approach the door, I know how to open the door, I know how to go through the door. I would not measure anything. I'm not interested in any coordinates, I just go. The traditional approach to robot control would be, I must know the exact coordinates of that door, I must know my coordinates, and then I can plan a trajectory that I should follow through the coordinate space, and so on. It's very complicated, and usually it's inaccurate, and easily it may happen that instead of walking through the door, I try to walk through the wall, and I hit my nose, which can be painful. So the next point is we should have a very natural way of communication, intuitive way of communication. So the robot should communicate in a similar way as persons do. Sorry. Let me explain again. Today's robots, especially industrial robots, usually are controlled by an exact formal language. They must be taught their trajectory. If the robot is supposed to perform this motion, then some engineer has to decide, okay, this point, this point, this point, and describe the trajectory by a mathematical equation. And then the robot can receive commands, as you see in the upper one of the yellow boxes. Go to x equal 10 point something and y something, velocity something. Well, no normal person can understand that. No normal person can communicate with a robot on such a basis. What we want to do is nature-inspired communication with that is based on natural language in the first place. And it should not use any coordinates, rather it should be augmented by gestures. I should tell the robot, go that way. The robot should understand that. So we need a robot that is able to understand dialogues as people use it. And when we talk to each other, we don't say everything explicitly. We see the world, we understand the situation, and we know that our partner also sees the world and understands the situation. So we can talk very briefly, and a typical dialogue between the user and the robot may be, the user says, put that on the table. Okay, what is that? The robot should know what I mean when I say that. But there are two tables, so the robot says, I see two tables. Which one do you mean? No, I don't want to give coordinates of the table. I just say, well, take the small one, take the left one, take the green one, and so on. The robot should understand that. And I should not repeat the entire command. Just this one ambiguity should be dissolved. So that's what I mean by a human-like and natural communication. I'm running out of time. Sorry. So this essentially repeats what I have said already. I just emphasize that human conversation is usually multimodal, not just voice, but also gestures and facial expressions and touch when I offer something to the robot or take something from the robot. And to be able to communicate naturally, the robot should use the same kinds of modalities for communication. So our robot can communicate in natural language. In Europe, we have many languages, so the robot can communicate in English and French and German. It can use gestures for communication. For instance, when I ask the robot, where is the auditorium, the robot can say, this way. So with its head and with the arm, it can point into a direction, and it can generate such gestures from an internal map. I must speed up. Let me just emphasize the importance of field tests. I said already it's important to test the robots in different environments, and I will later show you such tests. So we had a large variety of tests while we developed our robot in different environments with different people. And I will just show you one example, in a moment. Where are we? So I will show you a video. And in this video, please assume that in some time in the future, people will be able to go to a department store and to buy a robot that should work for them in their house or in their apartment. Now this robot will come from a factory, and the factory has prepared the robot. So the robot has much knowledge built into it. It has a vocabulary, and it knows little facts like water can be carried in glasses. Water is often found in kitchens, and so on. Thousands and thousands of little facts are stored in the robot. And the robot has some abilities. It can understand language and speak. It can build a map of an environment. It can navigate, and so on and so on. But it does not know everything. It knows nothing about my apartment if I buy the robot. And it has to learn everything. So Please try to remember the first day when you came to this university. You were in the same situation. You had studied many years in high school. You knew a lot, many things, language, history, mathematics, and so on. But now you are here. You don't know where's the administration office, where's the cafeteria, where's this, where's that, what's the name of the professor? Nothing. You have to learn it by observation, by looking around, by talking to people, and the robot is in the same situation. And now I will show you in a video how the robot can do this learning process. Please imagine that somebody has just bought the robot, and it's now being switched on for the first time, and you will see what happens. The robot will at first ask many stupid questions, and then it will get smarter and smarter and get more and more useful. And one point is important. Maybe you have seen robots in the movies. These robots are very, very good. They know everything. They are strong and they are perfect, but they are not real. Behind such a robot in the movie, there is a group of 3 or 4 people who are busy operating the remote control, and that's why the robot is so good. What you see in my video is real. Nothing is pre-programmed. Nothing is remote controlled. The robot acts only autonomously, only based on its own sensory information. So I hope it works. Isn't sound working? That's too bad. It's a video with sound. I have told before that I need sound, but no loudspeakers are connected, it seems. So you can hear how the people and the robot have a dialogue. You can read it, but it's nicer if you see it, if you hear it.
Yes,
How would you like to call me?
I would like to call you Hermes.
Understood. My name is Hermes. Rainer, please tell me where I am.
You are in my office.
Acknowledged. I'm ready to provide some services. In the beginning, I will need some time to learn more about this new environment. Anyone who wants to use my services will be able to define locations and objects of interest, and to have his own naming preferences. I can start right now to offer my services to you, or explore the environment on my own. What should I do for you?
Explore the environment. Come back to my office in 3 hours.
Understood.
The robot uses vision for navigation. It essentially follows the wall. Now it turns around the corner, and while it moves, it builds a map. You can see the map building process on the screen now. You may ignore the one line, the lowest line, but the other lines are for the map. So whenever the robot turns a corner or passes through a door, it enters some item in its map. And later it can use this map for navigation.
Hello.
Follow baseline cancelled. Current command cancelled. Hello.
Who are you?
My name is Hermes. I'm a service robot.
What can you do?
I can offer some services such as fetching and carrying objects. I can give you some information about this environment. Retrieve some information from the World Wide Web for you, or simply entertain you. What can I do for you?
What date is today?
Today is Monday, December 10th, 2001. What else can I do for you?
Bring me some water, please.
Can I find the water in the kitchen?
Yes.
I do not know where the kitchen is. Please tell me.
Turn left at the end of the corridor, turn right at the next intersection. Enter the room to your right. The kitchen will be located there.
Where should I carry the glass of water?
Bring me to my office, please.
Please, tell me your name. I need to associate it to your office.
My name is Ines.
Ines, please tell me where is your office?
My office is located at the door behind you on your left.
Okay, please wait. I will be back as soon as possible. I have detected one baseline.
So based on the woman's explanations, the robot constructed an abstract map, and now it follows this map while navigating to the kitchen.
Hello,
Hello.
is this the kitchen?
Yes?
I need to get a glass of water. Could you hand over a glass to me, please?
Yes.
The robot is lucky that there's somebody to help him.
I will take the glass with my right hand. Please, hand over glass. Thank you. My
Welcome.
Wonder run successfully finished. I have detected one baseline.
The robot is in a testing mode, so it explains many things that it is doing or seeing or thinking. This can of course be turned off.
Follow baseline successfully finished. Hello.
Hello.
Should I hand over the glass to you or place it somewhere?
Please hand it over to me.
I will hand over the glass with my right hand. Please, take over glass.
Thank you.
What else can I do for you?
What is the actual weather report for Munich?
temperature is 2 degrees Celsius. Mostly cloudy. The humidity is 87%.
Thank you. You may go.
Bye-bye.
When a question is asked, the robot tries to find the answer in its own database, and if it cannot, it tries to find the answer in the internet. Therefore, the robot is able to answer questions about the weather.
I have detected one baseline.
You remember the original order was for the robot to explore the environment for 3 hours. This was interrupted by the girl who wanted water, and now the robot continues to explore the environment. But because we are running out of time, I will skip it and come to the conclusions. So, what did we see? We should use a systematic design process when designing such complicated systems as personal robots. And we should base our design process on a few explicitly stated design principles. We have robots, by following such a design process, we have been able to build a robot that is intelligent, user-friendly, safe, and has some other desirable characteristics. We think that in the future, such design principles will allow us to develop robots that will be truly useful for society, but still there's very much work ahead of us. And as I said in the beginning, it will be a challenge for generations of engineers to follow. So here is here's where you can find additional information. It's the homepage of my laboratory. Thank you for your attention.
Thank you very much, Professor Volker Graffe. I would like to save the QA session for Professor Graffe for later, since we are a little bit behind schedule. At this moment, I'd like to invite Professor Virachai Kosuwan, the Vice President for Research, to present tokens of appreciation to our two keynote speakers, Professor Noboru Sonehara and Professor Volker Graffe. Thank you very much, Professor Virachai. Thank you very much, Professor Noboru Sonehara and Professor Volker Graffe. And now it's time for the first oral presentation sessions of today. Please check with the staff in the front which room is held for which presentation, and we will continue with the oral presentations to the rest of this afternoon, and we will meet again at this room at 3:30. Thank you very much.
กสรรค์ดังวิมานเหนือคำจำนันร่มสวรรค์ดังฟ้านั้นแสกสรรประทานยามนี้จำไกลดวงใจของฉันมองไม่แสนเศร้าหรือไทยสุดหักใจหลงรักมีคลายแต่ก่อนนั้นความสัมพันธ์เคยแนบแอบกายหักใจไม่ไหวอยากเยี่ยงกลายหายเศร้าระทมมอดินแดงยามนี้คืนนี้เดี๋ยวนี้คงเศร้า